Hello all, this is Arjun. So in our previous videos, we studied regarding our design of IC engine components, cylinder liners and its types, right? So today we'll study bore and its and length of cylinder, right? So what exactly is bore? So bore means inner dia of the cylinder, right? So bore is inner dia of my cylinder and length is somewhat length of the whole cylinder, right? So length has two things. One is the stroke length and the length of cylinder. I will be explaining you thoroughly in this video, right? So how I will be calculating dimensions of cylinder? So I'll be using this applied thermodynamics equation, which says IP is indicated power or power produced inside cylinder, and BP is my brake power or power developed at crankshaft. C, and this is my efficiency, mechanical efficiency, right? And this efficiency will always be less than 1, right? If suppose my efficiency is 100%, so it will come equal to 1. If it is 90%, it will come to 0.9. So it cannot be greater than 1, right? So it should be less than 1 always, right? Okay. So what exactly is indicated power and what exactly is brake power? See, indicated power is power produced inside the cylinder. See, some work is happening or some combustion is happening or process is happening, right? In my two-stroke engine, in my four-stroke engine, some power is getting generated, right? So this power will be transmitted where? To my crankshaft. And while transmission of the power, there could be some losses due to many factors, many factors. It could be friction, it could be anything, right? So some power will be lost. So just remember, my IP, which is indicated power, will be greater than my brake power. Always will be greater or equal to. When it will be equal? When my efficiency is 100%, which is almost impossible, right? So it will be always will be greater than brake power, right? So my IP will be always will be greater than brake power, right? That's why I am be using this factor, which is efficiency. Okay. So IP is in watts, brake power is in watts, right? Watt is Newton meter per second. Okay, right? So what is my small n? Now comes our small n, capital N. I'll just explain you. Small n is nothing but number of working strokes per minute. Number of working strokes per minute, and my capital N is engine speed, which is in rotations per minute. Okay. Now our next equation comes this one, which says indicated power is equal to indicated mean effective pressure into length of stroke, which is in meter. I will explain you why we are taking length of stroke in meter. Then our area of cross section, which is in mm square. I will explain you again. And this is small n, which is in per minute. Okay, strokes per minute. So let's do dimensional analysis. IP we have in watt equal to PM. PM we have in Newton per mm square. Okay. Then we have length in meter. Then we have area in mm square, right? Then we have small n, which is we have in per minute, but here as you can see 60 here, so it will get converted into seconds, right? So mm square gets cancelled, so we are left with Newton meter per second, which is equal to watt. So dimensionally I feel this equation is absolutely correct. Okay, so that's why we are taking length in meter, so to maintain my dimensionally, and this is correct. Okay, let's go further. Yes, so now my area, which is I'll be calculating by this formula, which is pi d square by 4, where d is diameter of cylinder or bore. in mm. Okay, then comes L by D ratio. So what is my small l? Small is nothing but stroke length. Okay, so there is a difference between stroke length and length of cylinder. I will explain you. See, this is the length of whole cylinder. There must be some clearance here and some clearance here. See, the piston will move up to, hold on a minute, I'll just change the color. Yeah, the piston will move till this point, from this point, and this is the clearance. Okay, this part which is the gap, it is the clearance. Okay, so piston will move till the red line. Okay, so this thing is my small l, which is my stroke length, and the whole length is my capital L, which is my length of cylinder. So this is the difference between the stroke length and length of cylinder. Okay, right. So my L will always be greater than small l, right? So my length of cylinder will be always be greater than the stroke length, always. Okay, so L by D ratio is assumed to be 1.5. Okay, 1.5 if it is not given, else it fluctuates between 1.25 to 2. Okay, right. So total clearance in both sides, it is assumed to be 15%, means small l, sorry, not small l, clearance is equal to 0.15 or 15%, or 15%, sorry, C is equal to 0.15 L or 15% of stroke length. So my L is equal to small l plus clearance. Okay, as I already showed you via the diagram how this thing came. L is equal to small l plus clearance. So it will come, my L will come equal to 1.15 L after I'll be adding this. Okay, this is my clearance, this is my stroke length. So in my next video I will do some questions regarding on this. Thank you.